Hey everyone, Tobi from Humanitec here. Today I'm going to talk about configuration in your platform. When you provision cloud resources through your platform orchestrator, you will have to configure those resources in some way. You'll have to say, what is the name of a resource? What is the region it runs in? What is the standard size of a database, etc., etc. And you will also want to enforce certain standards for your resources, but at the same time also provide some flexibility to your developers to pick a certain configuration. How to combine all of those things and make it work automatically? Well, let's take a look at how this can be done. Here's a very simple sample application. It just consists of one workload depending on an S3 bucket, could be any other type of resource as well. The S3 bucket has three properties. It's got a bucket name, a region it runs in, and a set of tags to support your cloud governance. Now, you will not want to hard code the values of those properties into the code base of that S3 bucket, which would be the resource definition of the S3, because doing that would make it completely unflexible and not usable across applications and across environments. Instead, you will want to inject those values from an outside source. The way you can do that is you provide another resource definition of type config, which exists for just this purpose. This config resource definition can then provide those values like the tags and the region and the name and the prefix. Let's split this up to the S3 bucket by having it reference that resource definition. We're going to look at how this is done in code in just a minute. That resource definition of type config is being maintained by the platform engineering team. So here's your PEs. And by providing that definition, they determine what are the defaults for this type of resource, in this case for my S3. So that was the default prefix, name, region, and tag for any S3 that's being provisioned. Now I mentioned that you can provide a way to override certain values for your developers. How do you do that? Well, you can set up a secondary layer of configuration by having that config reference another configuration which is being maintained by the developers. So here's another resource definition of type config, and it gives them a way to provide overrides. And you can set it up so that they can override some values, but not all of them. For example, you can allow them to override the prefix and the name, but not the region and not the tags, because those are the things that are important for your cloud governance, and you want to have your hand on that at all times, right? So you allow them to override the prefix and the name. They will override the default values and eventually make their way into the bucket name. But the region and the tags will always be sourced from the default config provided by the platform team. So there is some flexibility for your devs to override some values, but not a chance to do great damage, and you're still in control of the things that really matter to your cloud estate. Cool. Let's take a look at the code base, see how that is implemented. Let's start at the right-hand side of the picture, because that's where the action begins. So this is the config override for the developers. It is a resource definition of type config, and it's very, very simple. It just uses the echo driver to provide a set of values. In fact, it's just one of the values. So this example just overrides the prefix with a certain string called overridden. So that is the output of that resource definition. That resource definition in turn is being referenced by the middle piece, by the resource definition config of the platform engineers. This one is a little larger, but let's take it one by one. So that is the platform default type config, and it uses the template driver. The template driver gives us a way to provide some logic, because you can use Go templating language to do stuff and have a little more flexibility. First thing it does is reads the overrides from the developer overrides config right here. So it references a config type resource definition with a class of developer overrides. So the output of that other resource definition are now in the overrides parameter. And then it uses that parameter going forward after defining its own defaults, which are right here. So this is the default region, the default prefix, name, and tags are being constructed. And then the rest of the code basically just merges those two sets. So it takes the overrides, takes the defaults, merges them into one. However, it does not merge all of the overrides in. It does not merge any property that is called region or tags, because those are the ones that the platform team wants to be in control of. At the end of the day, all the outputs of this config are what is then being used in the actual S3 resource definition. Here it is. In fact, it uses just two of them. It's just a little bit simplified. And you will notice that this definition does not actually provision an S3 bucket. It's very, very reduced to what we want to show at this point. But there are these two properties, region bucket, and they are being sourced from the config that we just saw, and it reads the region and the bucket name from there. All of this code is available in our example library on the internet. We're going to put you the link to that source into the info box of that video. Going back to the real-life implementation, I deployed the sample code, performed a sample deployment, and this is the resource graph that was generated. Let's again start at the right. So that is the config resource based on the developer overrides definition right here, and we can see that it produced the value of the prefix. Going further to the left, that is the developer pattern, and we can see that it creates all of the values. It tags the region, it also has the prefix, and out of those two, it creates the actual bucket name. So that the actual S3 resource, which is right here, will then receive a bucket name, which is constructed out of the developer override plus the standard core name pattern for S3 buckets. Splendid. Cool. So that was a very simple example. The real world is a little more complicated, because in the real world you will have more than one application, you will have more than one environment, you will have more than one standard. So how do you do that? Well, you can expand on this pattern. So let's say you have two applications, each with an environment of development and staging. So here's app 1 and here's app 2, and both of them request an S3 bucket. So what you can do is you can provide different defaults for starters for those two types of environment. So you can set up a default config providing all of the values for development environments. And you can also provide a default config providing all of the values for staging environments. So that, for example, the region for S3 buckets or the size of the naming pattern is something different. And I made a mistake here. This is not development. This is staging. So this is config staging. Which can provide different values than the development one. And you can set the matching criteria for those two resource definitions in such a way that any deployment into development will source this particular resource definition, and any deployment into staging will source the blue resource definition. That's part one. If you want to have your developer flexibility, you can be as granular as you want. For example, you can give each application team their own way to override things. So at the top right, you can say in the Git repo of the app 1 team, you can have another config for type development and a config for type staging. where you can provide your own overrides applicable only, same mistake again, applicable only for your own applications. So here's a config override for development and a config override for staging. And you can give the same capability, let's duplicate that, save some time, to your application 2 team as well. So that when you have set up the matching criteria accordingly, any deployment, for example, for application 2 to staging, will effectively use this chain of configurations. And if that value has been overridden by app2 team, it will override the particular default and will end up right here and inform the actual deployment for the S3 bucket and staging for app2. As mentioned, you can be as granular or as coarse-grained as you want. You can cut it by application, you can cut it by environment, you can cut it by environment type. That is basically up to you, but using this pattern, you can be as flexible as you want or as strict as you want when it comes to setting configuration in your platform. And this is it. I hope this was very helpful to you. Feel free to apply this. Feel free to look at our example. And thanks for watching. Until next time, take care.